So today's session, again about Sky Pro Guide plan. I'm Dr. Johnson, working for Brident Medical, product manager for International CAD/CAM. So today's topic, it's a continuation of our from our module 1 to 3 are done. Today is module 4, and today's topic is about segmentation. So we will discuss about bone segmentation and teeth segmentation in both the DICOM files and also in STL files, and what is the purpose of all this segmentation. So before going into the segmentation, I would like to show our website where you can download the SkyPro Guide Plan software. And in the same page, we have added, and this is our website to download the software. As usual, I every time show this. And here is the new link we have added to the SkyPro Guide Plan same download area, webinars. If you click this, it will take you to this page where we have already uploaded module 1, 2, and 3, and today's session 4. Once the session is done, we'll be uploading 4, and it goes on. So this is a continuation of from module 1. We are going into the depth of the software as we go, and every stage has a continuation. So whatever we learn today, we'll be trying it on module from 4 to module 5 also. So whatever we learn today will be useful in the next modules. So we will be discussing about bone segmentation, teeth segmentation, and its refinement around it. So coming to segmentation, what is the purpose of segmentation? So I'll open a case and I will show you what is it about. So we have CBCT file, DICOM file. This is a volume file. So converting a volume file into the surface file is called segmentation in the ProGuide software. This CBCT with all these the way we have taken the CBCT, the quality, it converts into the surface. It is used for various purposes, for orthognathic purposes. If you want to print the bone model, or you want to design a bone graft, or even for bone guided surgical guides. So you can use for various purposes. As I have explained in the previous modules, I have crossed all these. I think you can see my mouse. I have crossed uh, even nerve detection. I have crossed all these. And now today's topic, segmentation, I will go into segmentation. So this star mark is segmentation. When you click this, you have few options of segmentation, starting with bone segmentation. I click on the bone. So here you see our CBCT file, which is a volume file. And we have few options here. So when you have upper and lower in CBCT, and then you click fill holes, and you can click automatic, and you have to manage your threshold, like how much ever bone you want to see. You don't want to see excess, and also you don't want to see bone which is totally gone. So you manage the threshold here. And the number of objects, what it does is when it converts into the surface file, now the numbers is 2, 3, 4, whatever number you want to number, you can number. So it'll save too large, like these small fragments also will be saved, and that many numbers. Like if I save as 2, then this one mandible file and one more fragment of this will be saved. So we don't want these fragments. We just want the large STL file. So we make it number 1, and then we click fill holes. It will fill all the holes and just make one surface file so that we can print. So I click on segment bone. So this is segmented bone, and you can, if something is not included or something like that, then you can use your you can see this my mouse which has circle. You can increase the circle diameter. So here it is add seed and remove seed. I'll tell you what exactly it is. In some areas, if for example Okay, in this situation, we want to make a bone model. That's why we have done this. But in some areas, if this the furcation is not, you don't want to involve this furcation area, so we can reduce the size of this diameter. Click Control or Alt and mark this area, and this area of the bone will be gone. And if some situation, I'll undo it. In some situation, you want to add bone, then you can control and you'll get the green area, and then you click this, it'll add the bone. You see, it has added the bone. So that's how you can add or delete the bone from the segmented um, STL file. Now this is an STL file for you. And in the next step, if you go, you can in fact smooth the surface if you wish to. You can smoothen the surface. You can erase things if you want. You can remove the surface. And this tool works both in 3D and also 2D area. Like this, for example, if you want to remove something, you can remove here. You can remove this area if you wish to. I won't do that, but just showing you. So this tool works both on 3D and 2D. See, this just cuts off everything. And then we can even make bone graft from here. For example, I'll show this. So let's imagine I select a surface, because all the cases are all the implant cases do not have sufficient bone. So that's why we sometimes we need bone grafts. And so we can select the area and create grafts. So what does this bone grafts help us for? All the cases don't have sufficient bone, so it helps you to simulate an ideal bone shape. Also, you can plan your grafts whenever needed. You can design guides and meshes even before surgery. And also it helps you a prosthetic driven augmentation. Why? Because you can understand how the gingival support is on the bone, how does your emergence profile come, and how does the papilla formation happen. You can understand all this with this kind of volume generation or bone graft generation. And at the end, you can decide the soft tissue and aesthetic outcome. This is also called as virtual bone augmentation or digital wax up of your bone. And then if you're happy with this, then we go, if you're happy with the area of selection, then we can go with the next step. And then we can adjust, we can cut the area which we don't want, or we can smooth the surface. You can smooth the surface. So you can make a bone like this, or you can even create a screw channel here. Uh, like even that you can use it as for making a titanium plate. And we have one more option called define pattern. So here we can decide the pattern in square or circular, or and the diameter and pattern size, and then create graft. So we have graft with pattern. So this is one of the uses of making segmentation. Then I will revert back to the starting step again. Now there is one more segmentation, automatic segmentation here. Till now we have worked on the lower part. Now I will show you what is this kind of bone segmentation. Here there are two options. One is include teeth and without teeth. So I will do it with include teeth in the beginning. So I have switched on include teeth and say segment mandible. Of course, this is mandible. This whatever I'm pressing here, X is hiding or showing of DICOM. So I'm hiding the DICOM, and this is your segmentation. I will undo and redo with by switching off including teeth. So this one has done including the teeth as one STL. Now I undo it and switch on the DICOM, and I say do not include teeth, and I segment the mandible now. This is a very interesting topic. It's not straightforward like implant planning, guide designing, and printing the guide, and then you start surgery. This is more than just implant planning and surgical guide. This can be used for orthognathic and reposition of the teeth. So now I switch off the DICOM, and now you can see it with extraction sockets. So you can literally do the case where the patient's original in the patient practically physically the extraction is not done, but you can virtually do extraction here, and then this particular STL file, I'll show you the next step. This particular STL file, you can do anything you want. You can smooth the surface, or you want to cut by area. I'll just show here cut by area. And in this, with this, you can do a lot of other planning like stackable guide, or you want to do bone reduction guide. You want to reduce this bone with bone reduction guide, which will be I'll be explaining this in the next module. So you can do a lot of things with this. I will show you again, finalize. Yes, save segmentation. So we will save it as segmentation. Okay. And if you see, I'll go to all the data files. Here is my STL file here, and I can go to edit, and from here I can either cut, or I have all the options to cut particular play area. We have STL file, but this STL file is a solid STL file and doesn't have the nerve path for to guide the nerve. Where is our nerve? When you do a 3D printing, and if you are planning to do orthognathic surgery or demo on this, you need a nerve file also. So we have Boolean operations. Go to Boolean operations, and we select the mandible, and here we select the nerve. So we have a left nerve, and we say subtract from. So the nerve will be subtracted from the mandible. And now apply. So now this particular bone has a hole for the nerve. So when you see, I have done the cross section. If you see this, I have not subtracted the right, I have subtracted only the left just to show you. So you see when you print the model, you will be able to print along with the channel for nerve, and now you can do a good orthognathic surgery. Here are the extraction area, and you have nerve along the way. This is very interesting. I find it very interesting, these things, and finalize it. So I will go to the next part of segmentation. We have done bone segmentation with extraction socket. The next part of segmentation is teeth segmentation. So I will click on this tooth segmentation. So we have CBCT file, and I say automatic segmentation. It's locating all the teeth. The better the DICOM file, the better the result will be in this particular part. So now it's identified the teeth, each teeth, and now it's segmenting. So it will take some time. If you don't want to segment everything, all the teeth, you want to segment specific teeth because which will be going under extraction. So you will let it be, and the rest of the teeth you can just click on Alt and click on the minus, and you don't want to extract these particular teeth. So I will let the other rest of the teeth to be extracted. So this part definitely needs very good processor. You can see. So the extraction is done. The segmentation is done. I will switch off the CBCT file, and then now you can see your STLs, teeth STLs. Here the list of teeth STLs. You can switch off and switch on anything you want. So we have extracted 4, 6, 4, 7, 4, 5, 4, 3, 4, 1, 3, 2, 3, 7. Okay. Now next, here again, if you think something is not right, you can always go and smooth it. If you're happy, we can just finalize this. Save project, save segmentation. So you have extracted bone and extracted teeth individually. So before going, how do we use this teeth? I will like to show crown the teeth extraction from the STL file. So there is an option, segmentation. Now you go to the top option, crown. Click on the crown, and this will extract the teeth from the STL file. And if you click on this green extract gingival segment, after extraction of the teeth, whatever gingiva is left, it will keep an extra STL of that extracted STL file. So we click on automatic segmentation. So it has selected the teeth. We don't have 4/8 here, so we remove 4/8. And we don't want to extract everything. We want to extract only few. Then we can just switch off few of them. Likewise, like this. And then if you're okay with this, then go to next. In this part, you can edit if you think the margin lines are not correct here. So if you think you can just draw here, for example, this one, you can just draw a new line here. You can draw here any teeth you want. This is overlapping. You can draw this, and this one you can draw it here. So if you think you're happy, then go next. Then next. So you have 4, 7. All your crowns are here. The crowns. This particular, because of the adjacent contacts, your crowns are not complete. So what we can do is, for example, this particular teeth, 3, 7. We go to border restoration, and then we click from this part to this part, and you will see this filling. We can curve it little to make it look like a distal mesial contact. we are trying to make it a complete crown and then apply, and then finally use a smooth tool to smooth the surface. So this ones you can use it as a wax up for next implant with crown. When you are planning an implant, you can use it as a wax up. And this same wax up can be used in prosthetic part, where you can make a prosthetic design exactly like this and you can mill it. So prosthetic driven implantology. So next, you also have gingiva. As I said, you will get an STL file with extracted teeth and gingiva. Here you want to close the holes. So fill holes and select the holes which you want to close and fill them, either curved or round, fill them. So it will fill up. I'll Curved is giving a convex surface. I would like to have round. And fill it. So this will give little concave. If you want to try, we're trying to give extraction socket-like appearance. So again, from freeform tools, we have minus. We can increase the strength and we can try to give this like extraction, or we finalize it, save it. We have objects, have so we have individual crowns like this. We can use them, or we go to Boolean operations. So we have this particular file. And for example, we take tooth maybe 4, 5, and we say subtract. So we are subtracting 4, 5 from the anatomy file here, and then click apply. So it gives you the extraction like format with the root on your STL file. So you are digitally extracting. So either you can extract and make your own soft tissue here, or you get extraction like this, extraction socket like this, and then finalize it. So you have your file at the bottom. You go to edit. You can select cut by area. You don't want this entire root. Cut it. Oh, spleen. Yeah. So you try to cut again how much ever you want. Cut. And now we go to fill holes. Select this particular hole and fill it up. So you have a shallower, and then you can smooth the surface from inside. You can use different tools to fill up the hole, smooth the surface. So this is how you use segmentation for different purposes to create STL files from the bone or for surgical guides. So any questions here? I'll just explain about saving. So I have been saving segmentation every time. So uh, each project you can save in for example, if you have planned one position and then your doctor wants in another position also, so you can have multiple save options in the software. For example, now I click on save. Till now we have seen segmentation save. We can also save segmentation second now, for example, and then click OK. And I say exit. So if you see, this is the patient's name. This is the patient's name, and this is if you leave the computer for some time, the software will autosave. It will be named as autosave, and whatever we have worked and we were saving, it will be saved as segmentation, and segmentation 2 is a new save. So this and this are not disturbed. So you can have implant position 1 and name it as implant position 1, and again change the same implant to position 2, and you can save as segment 2. And to the doctor which you are sending, if you want to send both the implant options, both the positions, you can share the patient here, click here and send it to the doctor to his email address, whichever email address he has registered the software in. And if you don't want to send the entire case, you want to send only one position, you can upload here and share the file to that particular doctor. Only this particular part will, this particular section will go to the doctor. So today's session is really short. It was only about segmentation. The next session will be on surgical guide. I had to explain this bone segmentation in a separate module because once I get into surgical guide, bone segmentation and surgical guide both together are a little confusing to explain in one session. That's why even though it is short, I had to keep bone segmentation in a separate context. I will see you all again next month again with a very important topic, surgical guide. I will explain all the variations of surgical guides from simple surgical guide to stackable guides, how to connect them, how to connect it to prosthesis, and how do we make bone surgical guide. It's a complex topic. It will be a little longer session than this. So make sure you all attend the next session. So that's all for today's session. If you have any questions, I'm here. Otherwise, we are done for today. Thank you. Thanks a lot.